So welcome everybody to Computer Science Orientation for June 2020. I am in fact not Sarah Klinkbeil. I am actually Danny Vanderhorst. I'm also an undergraduate program coordinator for computer science. I'm stepping in for Sarah today, however, she's not feeling too well. But for any first years, Sarah is your go-to girl. So please take note of her email address on the screen, sklinkby@cs.rochester.edu. She is your point of contact, and all questions for incoming students should go to her. So everybody should be on mute, so that's good. And the session is also being recorded, so if you ever want to go back at any time to double check on information, that'll be available, I believe, through the orientation website. And then we'll have a Q&A following the session, so feel free to use the chat feature to ask questions throughout the presentation if you have them, and I'll be answering those in the chat session, okay? So I'll introduce our main speaker for today, Professor George Ferguson. He is co-director of the undergraduate computer science program here at University of Rochester. Email address is there, so you can always send him questions if you have them. And George, I'll pass it off to you.
Okay, thank you very much, Danny. George Ferguson here. Glad to have you along. Talk a little bit about computer science at Rochester. Let me just say we want to make sure that this is interactive, but we've also got a few things that we need to tell you. So feel free to ask questions in the chat, either publicly or to Ms. Vanderhorst, and we'll queue them up and try and answer them when we have a chance. And then at the end, we'll open things up for we can also do some questions in person. Okay. So let's roll. So computer science. So you're here, I hope, because you're interested in computer science. That's awesome. So I think what I should do is start by talking a little bit about what computer science really is. Next slide, please. So of course, computers are in almost everything we do these days, right? Web servers, cell phones, medical devices, gene sequencers, toys, airplanes, drones, self-driving cars. So cool, right? Lots of stuff. But computer science isn't any of that stuff, right? Computer science is the science that's behind all of that stuff. Next slide, please. So if you really strip it down, computer science is fundamentally about two things, okay? It's about, number one, computational methods for solving problems, okay? We call those algorithms. You'll be real familiar with algorithms after you've studied computer science. And then computer systems, computational systems that include computers that implement those algorithms and apply them to problems and become the foundations of all those cool things that we just saw on the other slide. Okay, next slide, please. When you study computer science, you become a computer scientist, okay? You understand algorithms. You know how to use algorithms for solving, to create computational systems that solve problems, whatever the problems are you want to work on, okay? And these days, actually, what's really interesting is that almost any problem, right, has some kind of computational angle. It either is a computational system or it involves some kind of computational system or computation, okay? So the applications of computer science are really wide-ranging, and so there's a ton of interesting things that you as a computer scientist can get involved in. Next slide, please. This is a graphical display from one of the big international computer science associations, okay? And computer science is all these things. These are actually the top topics from their curriculum guide. Okay, computer science is all these things, okay, and more. And as a computer scientist, you'll learn about all these things. And then you'll go on and you'll discover new things, right? That's what scientists do. We discover new things. You'll discover new things that people have never thought of before, okay? New applications of computing, new fundamentals of computing, whatever, okay? So like I say, that's what scientists do. Okay, and I hope that if you're interested in computer science, I hope that that's what you want to do, okay? And that's why you're here listening to me talk about computer science and asking questions about the computer science program at Rochester. Okay, next slide, please. Okay, so that's the big picture of what is computer science. I'm going to talk a little bit about the computer science department and program at Rochester. I'm going to give some suggestions and tips for getting started in computer science, so computer science for first-year students at Rochester, and then we'll spend most of the time answering your questions if you have any. Okay, so next slide, please. So let's talk a little bit about the Department of Computer Science. So it was founded in 1974, and it's kind of interesting. It was a research-only department. There were no undergrads. There were grad students. They were PhD students only, and they were really basically doing research. Okay, there weren't so many courses exactly. Top-tier research department. The graduates of that department, the alumni of that department, are all over the map in computing and computer science. You can find them anywhere. The undergraduate program started about 20 years later, and we really tried to emphasize in our undergraduate program the same approach that we took in our graduate program, which was an emphasis on the fundamentals of computing and on cutting-edge research in computer science. Okay, and you know, as you go on in our program and as I talk a little bit about it the rest of today, I think you'll see what I mean by that. Our undergraduate alumni go on to grad school. They go on to all the big companies, government agencies. They go on to all the small companies, the startups. Many of them start their own companies or get involved with starting their own companies. So again, the computer science degree at Rochester, whether graduate or undergraduate, is a connection to a whole lot of people doing really, really interesting and important stuff after school. Okay, next slide, please. So the undergrad program specifically, I'll just say briefly what we offer, and then we'll talk a bit about some of the details. So there are two major degrees in computer science. We offer a Bachelor of Science, BS degree, and the way I bill it is it's all of computer science, okay? It's everything you might need to know, everything we can teach you in 4 years, assuming that you also want to sleep and take some other courses and do some other things. And but it's all of computer science in 4 years. We offer a Bachelor of Arts, BA degree, also provides very solid grounding in computer science. There are fewer required courses, there are more options for electives, and it's really great for double majors. So if you're doing something else and you want a computer science angle to add to that, the BA is a great degree for that. We offer a minor. It's very straightforward. You take any 6 computer science courses and you can get a minor in computer science. And there's also what we call clusters. And if you haven't heard of clusters, you will. They're the distribution requirements that are required by the college. So if you're, say, a computer science student, you have to take some courses in the humanities and some in the social sciences. If you're a humanities major, you have to take some courses in natural science and engineering and some in social sciences. Okay, so our clusters in computer science are for students who are in humanities and social science. They're majors in humanities and social sciences. Okay, and those are 3 courses that sort of go together, and we offer several of those. If you're here because you're interested in the major, you're not interested in the cluster in computer science, but if you're interested in computer science but thinking of majoring somewhere else, a cluster is a great way to start. Okay, you can turn a cluster into a minor by taking a few more courses, or even into a major. So, okay, next slide, please. So just quickly to give you a sense of what you're signing up for when you decide to become a computer science major, I'm going to run through this quickly, and the slides, I'm sure the orientation people will make them available to you, and we'll help you get this information also. But like I say, there's 2 major degrees. There's the BS and the BA, and the first thing to realize is that they start the same way. So you don't have to know or decide what you're doing right now. Okay, they both start the same way. They start with CSC 171, Intro to Computer Science, and Math 150, which is discrete math. Okay, discrete math is the type of math that we use in computer science. That's followed by Computer Science 172, Data Structures and Algorithms. Okay, and both degrees require all 3 of those courses, and they happen in that order. Okay, then let's look over on the Bachelor of Science, the BS side there. What you'll see is that the BS requires some calculus. Okay, you'll do that if you haven't done it already. And then there's this set of 6 courses that represent the core of computer science. And that's what I mean when I say the BS degree is the whole enchilada of computer science, okay? There's these 6 courses that we really feel represent all the fundamentals, all the foundations of computer science, insofar as we can fit them into 6 courses, you know. And as a BS major, you take all 6 of those. So you get the whole enchilada. There's some additional math requirements for BS students, and then you take 4 advanced electives, okay? These are often upper level courses that the core courses have opened up for you, okay? So you learn something about the fundamentals, and then you say, oh, I'm really interested in operating systems, or I'm really interested in machine learning, or whatever it is, and you take your advanced courses in those, okay? So that's the BS. At the bottom there, you can see that the college requires you to take 1 semester of first year writing and 2 semesters of upper level writing. And then also your clusters, as I mentioned. So if you're a computer science major, you're gonna have to take a humanities cluster and a social science cluster, and you'll go find the subject and the particular cluster, the particular sequence of 3 courses that interests you, and you'll get started on those early, and they're great. They'll really inform your other work in computer science. You know, sometimes, like I say, it turns into a double major or just gives you a different perspective on something. So that's the BS degree. If you compare the BA degree, you can see what's the difference. Well, they start, like I said, Computer Science 171 Intro to CS, Discrete Math 150, and Computer Science 172 Data Structures and Algorithms. They start the same. There's no more math for the BA. You only have to take 2 of the 6 computer science core courses, but those are real core fundamental computer science courses, okay? You just don't have to take them all. And then you have to take 7 electives, and there's a few more options to choose from than there are for the BS, okay? And you still have to do the writing requirements and the cluster requirements. So like I say, the BS is really the whole enchilada, all of computer science that we can fit into 4 years for you. The BA, solid foundation in computer science, more flexibility for you. Okay? I'm happy to answer more questions about the details of this when we open it up for questions. Okay, anything else? Let's see. No, I think next slide, please, Danny. Okay, so it's not all about coursework. I just want to touch on a couple of the other aspects of the department that are really relevant for undergrads. So the first one is undergraduate research. So as I said, we started as a research-only department, and we still have a huge research focus among our faculty and our graduate students. There are opportunities for undergraduates to get involved in research. I'll just mention 2 things about that right now. Number 1 is, when someone comes and asks me, a student comes and says, hey, I want to do research in computer science. I go, that's fantastic. Okay, that's what we're all about. Here's what you have to understand. Research is about expanding the boundaries of what we know, okay? In order to do that, you kind of have to know where those boundaries are, and then you have to know enough to be able to expand them, okay? So, you know, undergraduate research, real research, where you're doing something that nobody's done before, you're figuring out something new. That's not something that usually happens right at the beginning of your college career, okay? It's really more something that you work your way up to as you start to take the core courses in computer science, and you get into advanced electives, and you make connections to faculty who are doing research in an area that you're interested in, okay? So that's how that works. There's some other opportunities for undergraduate research also, and we could talk about it if you're interested. The other thing to say is we have an honors research track in the BS. So if you're a strong student and you develop a research interest and you start working with a faculty member towards the end of your career, so maybe as you know, the spring of your junior year, looking ahead to your senior year, you can sign up for the honors research track, and that allows you to basically do something completely new. It often results in publishing an academic paper with your name on it or with you as the author. And so that's for people who are really planning on a career in research. Okay, a couple of organizations to mention, and you can look them up for more information. We have Undergraduate Council, the CSUG Undergraduate Council. You know, they're sort of the official student group of the department, so they look after things like tutoring, they run a big hackathon each year. I don't know how that's going to run this year. We'll see, but they do mini hackathons. They do virtual hackathons. So there's all sorts of opportunities for that kind of thing. They run coding challenges. A lot of companies these days interview you by giving you a coding challenge or some kind of challenge like that. And so it's great practice as well as kind of fun. They do social events, especially they're good to connect you with alumni and employers, things like that. Okay, so that's a great resource. And that's, like I say, the official group for the department. Second, the Women in Computing and Minorities in Computing group. Again, this is open to anyone who's interested in supporting underrepresented groups within computer science. And they do a lot of things like peer mentoring, okay, which is great. Social and professional events. They do some community outreach where they go out into the schools here in the city of Rochester and teach kids. They focused on the Girls Who Code group. And so they try to get kids started in computing, especially girls. And so a bunch of things like that. Okay, so another terrific group, both as a resource for you if you come as a student and want some help like that or participate like that, and also for you to participate and share your skills. And the third one there, the UR Robotics group, okay, it's what you'd expect. It's a robotics club, student-led projects, things like they were working on an underwater robot, they were working on robotic hands, they do some competitions, some robotic competitions, and they do a bunch of workshops on topics relevant to computer science. So I happen to know that they're doing, in the fall, they'll be doing a workshop actually on one of the subjects that I'll be teaching in the fall. So, you know, for the students who are in my course, they'll get that for free. So a lot of things like that. Okay, we can answer more questions about these if there are any questions afterwards. Okay, next slide, please, Danny. Okay, so that's the basic view of the department and our degree programs. For those of you who are considering majoring in computer science, let me give you a little bit of advanced information on what you might do in terms of registering and thinking about courses for the fall. Next slide, please, Danny. Okay, so the first thing to say is that if you want to start a computer science major in the fall, you really should be declared as a computer science pre-major. So you should say that computer science is your #1 interest on your orientation forms. It's not the end of the world, you can change it, that's fine. But the reason I say that is that if you say that you're interested in computer science, you'll be assigned to a computer science advisor and we'll give you advice prior to registration in August. Okay. Also, some of the courses are the computer science pre-majors have priority for registration. I apologize for losing my train of thought. There's a howling dogs all around me here. Anyway, computer science pre-majors get priority registration for the first year courses. I don't see that being a big problem this year. All the available spaces are opened up to everyone afterwards. But if you're sure that you want to start a computer science major in the fall, then you should make sure you indicate that. And we're happy to answer questions more about that after the talk also. Next slide, please, Danny. Okay, so if you want to start computer science, so what courses should you take? So a standard load at University of Rochester is 4 courses. So let's just talk about what they might be quickly, just to give you an idea. It's really not hard. You should take 1 computer science class, your first computer science class, and you should take your first math class at University of Rochester. For most students, this will be Computer Science 171, Intro to Computer Science, and Math 150, Discrete Math. Okay, I already mentioned that. For most students, whether you have any experience with computer science or not, with computing or not, that should be your choice. Students who got a 4 or a 5 on the APCS exam can receive credit for 171, and they get placed and allowed to start in Computer Science 172, Data Structures and Algorithms. And those students would also take Discrete Math, Math 150. They would take it as a co-requisite, whereas normally it's a prerequisite, okay? If your background in STEM subjects you know, is maybe not the strongest, or you just want some more time to prepare and adjust to college level work, or you just want to start computer science kind of slowly, you're not sure, that's no problem also. Computer Science 161, Introduction to Programming, is what we would recommend you start with. And also Math 140, which is Foundations of Calculus. Okay. You would then go on, if you say, hey, that worked out pretty well, I like that, I'm off to a good start, then in the spring you would take Computer Science 171 and Math 150, and you'd just be rolling along in the program. Okay, next slide, please. So those are 2 of your 4 courses. The other 2 are really up to you. The first is that you should try to take first year writing 105. There are many, many, many sections, like hundreds of them, and they're all small. You should find some that suit your interests and fit with your schedule for these other 2 courses, for your 2 main courses. And you will try to register for them. There are enough places for half of the incoming class each term, okay? So if you get into it in the fall, you take it in the fall. If you don't get into it in the fall, you take it in the spring. You must take it in the spring. So best plan is to try to take it in the fall when you can find a subject or a topic rather that you like. And then you've got 1 course left if you get into first year writing, and you've got 2 courses left if you don't, and those will be cluster courses. So you'll identify a discipline and a cluster, one in the humanities, one in the social sciences, and you'll find the course that fits your schedule, and you'll take that course. Okay, and many clusters have lots of options for which courses go in the clusters. Okay, and we can give you links to that. In fact, there are links later in this presentation. Okay, so it's really pretty straightforward. It's your first computer science class, your first math class, and those are pretty straightforward. First year writing, if you get it, 1 cluster, otherwise 2 clusters. Okay, we'll answer your questions about that later. Next slide, please. Okay, so that sounds like kind of a lot to deal with, but I don't think it's too bad. I'm pretty sure you can handle it, and we'll be here to help you. We'll be reaching out to all first year pre-major computer science students. So the students who say, hey, I'm interested in computer science first, we'll reach out to you and connect you up for first year advising. And we'll do that sometime before the week of August 3rd. Registration starts August 3rd. Most first year students will register on Monday, August 10th. Okay. And then classes begin towards the end of August, just before Labor Day. Okay, I think that's it. Next slide, please. Oh, yeah, there's a whole lot of links here. I'm not going to read them all to you, and you're not going to crazily copy them down. I'm sure they'll be available to you, and we'll find a way to get them to you if they aren't. They're for looking for courses and getting some help with stuff and resources that are available to first-year students especially. Okay, next slide, please. Right, okay, so I think that's it from me. I think what we'll do is we'll take questions from you, and if there's any questions that have already been asked in the chat, Danny can ask them, and otherwise we can also call on people, Danny, so however you'd like to handle it, go ahead.
Yeah, so we do actually have questions in the Q&A right now, so we can just start by going through those. So somebody asked, can BS majors take more advanced electives if the student wants to and time allows? I'll just say yes. That's just a simple yes. Yeah,
there's the requirements for a degree are always the minimum. You know, you can take more. You're going to take at least 32 courses in your college career, right? 8 semesters times 4 courses. And our degree requirements that we listed there, you know, don't come close to using all of those. So you can take more advanced courses. You can take other disciplines that are related or completely unrelated. Lots of flexibility. The advantage of being a BS major is that you will have taken the prereqs for almost every advanced elective, okay? Whereas if you're a BA major, you've got to sort of choose carefully depending on what you want to do that's more advanced. Okay, next question. Somebody asked if, George, you can just briefly describe what each of the core courses go over. Sure. So there's 6 core courses, like I say. So our pre-major courses get you Intro to CS, which is programming with a CS twist. It's programming, but we know you're heading for a computer science major, so especially towards the end of the course, it's a little different than Intro to Programming. But both of them can get you started from nothing. Data structures and algorithms is where you start to think about, okay, well, you know, I always tell students, so in the Intro to CS class, if I ask you to write a program that, let's say, you know, sorts an array of numbers or something like that, a list of numbers, I'll got a class of 100 students, I'll probably get something like 80 different answers, and some of them will be right, most of them will be right, some of them will be wrong. Which one's best? What does it even mean to be best? How do we decide? You know, how do I know which programming technique to use for a particular problem? And so data structures and algorithms is about studying these patterns that recur constantly. Every time you have to solve a computational problem, you see bits and pieces that you've seen before in other problems. Okay, and so in data structures and algorithms, you learn how to analyze those situations and figure out which one is best, or under what circumstances is each of them best. Okay, and so those are common to both degrees, so CS1 and CS2, Intro to CS and Data Structures. So quickly on the core courses, so CSC 173 is called Formal Methods, Formal Models and Computation, okay? And it sort of goes the next step down that path. It says, okay, instead of asking which Java program is best for sorting a list of numbers, you know, let's talk about different models of computing devices, different models of computation itself. You know, can you compute anything? Or are there some things that some types of computers can't compute? And how would you know that? How would you ask that question? How would you answer that question? And then you can also build those models and see them do things that are used in practice. Okay. I'm not going to go in a lot of detail. I can later if we want. It's a fantastically interesting subject, and it's taking you to that next level of really understanding as a computer scientist, what are the principles of computation? Okay, so 173 would be the normal third course in the major. And then we've got 5 more. So computer science 242 is Intro to AI, artificial intelligence, popular topic these days. And it's setting the table for a large array of different upper level electives in other departments also these days that use artificial intelligence methods. Computer science 252 is computer organization, and 254 is programming languages. And so those 2 courses together teach you how computer systems really work. So how does a microprocessor or a processor and memory and devices and things like that work? How do you program those? It's a lot harder than writing a Java program. And then what happens to the code that you write in a language like Java or C or Python or whatever? How does that actually turn into something that runs on a processor? Okay, so they give you the foundations of computing devices, really. Okay, we don't go down quite to the level of the individual circuits and electrons and stuff like that. That's for the electrical computer engineers, but we get pretty close, and the line actually starts to get blurred, so it's pretty interesting. The other 2 core courses are CSC 280, which is, I think, called Complexity, and 282, which is called Analysis of Algorithms. And these are the mathematics of computation, okay? They are how we use math within computer science. So computer science is a science, math is the language of science, and 280 and 282 are where you learn at the core level how to analyze computational systems mathematically. Okay, we start that actually in 172, data structures and algorithms. We do a bunch of it in 173, formal models and computation. And you see it in the 2 core courses, 280 and 282. Okay, and all of those core courses open up upper level electives, upper level AI electives, upper level systems electives like operating systems and security and cryptography and stuff like that, upper level theoretical computer science electives, and actually crypto kind of fits in both systems and theory, so that's really interesting. So that's the way it works.
Okay, thanks, George. Next question, do you recommend a certain type or brand of laptop for a computer science major? Yes, I know it's been talked about among the faculty, and I know the tech store on campus does I think we sent them what we recommend to tell students, but I think, George, you can speak more on that and sort of like what type of processing power you might need on a personal computer.
Yeah, I mean, it's really a moving target, and it's really hard for us to say what's best and what's the right cost-benefit ratio for you. What I would say is you probably, if you're planning to be a computer science major, it's probably worth investing in a real laptop, whether it's a Mac of some kind, MacBook or MacBook Air, MacBook Pro, or a Windows machine. What I'm saying is a Chromebook it's hard to do programming on Chromebooks. It's great for lots of things that you have to do at college, so it's a perfectly good device for a lot of things, but when it comes to programming, it's difficult. It's not the easiest thing. And so if you think about it over 4 years, and if you're planning to use the same machine over 4 years, and by the end of it, you're going to be doing a lot of your time, with pretty serious programming, it probably makes sense to buy a pretty good tool from the outset, So the new MacBook Air is pretty good, and it's not the cheapest thing, that's for sure. There's plenty of Windows machines. I would probably not get the cheapest thing there either. And you can also learn, for example, when you get here, you can learn how to make either of those machines run an operating system called Linux, which is quite often used in computer science and runs a lot of the things behind the scenes, the web servers and the databases and things like that. So yeah, we don't have like a hard and fast rule, but if you're going to be a computer science major, you probably want, a little more juice to get started than a Chromebook or something like that.
Yeah, I will also just add as well, a lot of students will utilize, we do have a computer science majors lab that is in Wegmans Hall, which is the home to the department. So if you are living on campus in the fall and, I'm not sure what it's going to look like as far as access to those shared spaces yet, but in normal circumstances, there is the Comp Sci Majors Lab. You have to declare your major first, though, before you get access to that space, but we do have computers in there that are available for students to use as well.
And if I could just add, there are lots of UVAR IT labs. Again, we don't know exactly how that'll work this term, but provided you don't mind going into the lab to do your work, which actually for me, when I was an undergrad, that was a good idea. There are a lot of machines there that have all the tools that you need. And so, you don't even necessarily need to have something for the fall. You could wait and see. Although this fall, I don't know how those shared resources are gonna work.
So next question in Q&A is, can we start with calculus as the first math?
So the answer is, it depends, but generally speaking, no. The reason is that you need discrete math for CS 172. Okay, so if you take calculus instead of discrete math, then you're not going to be able to take CS 172 your second term in the spring. So what I would say is, if you're a very strong math student, there are some options to let you shortcut a few things. And by very strong, I mean AP math, AP calculus, ability to convince the math department that you're very strong in math, not so much me. And so we could work things out. If you're doing it because you're interested in double majoring physical science or engineering, which does expect you to start calculus and you kind of need to do it, I would strongly suggest that you focus on one major first, okay? And if it's the one that has the most requirements, like maybe one of the natural sciences or engineering, then you start with that and you lay down that foundation and you figure out how to fit computer science in. I'll say it's quite challenging to double major computer science and another STEM discipline. It's possible. Some are more amenable to it than others, but it's not easy. It uses up an awful lot of your courses. So the answer is, there can be circumstances where taking calculus in the first term is okay, but not at the expense of discrete math, and it's going to put you behind on taking your clusters. You really don't want to be taking first-year general interest courses when you're a senior. Okay, so you want to take your cluster courses early. That's what they're for, to give you some perspective on the world outside of math and computer science. And so we really encourage you to do that. But that'd be something to discuss with an advisor in person, look at your particular situation. But our basic advice is no, don't start with calculus.
Okay. Question after that was, can we still major in computer science if we take the first computer science course in the spring semester?
Absolutely. Absolutely. Yep. If you wait too long, you start to run into a problem of not enough, courses to get things done. Some things have prerequisites, and some courses are only offered spring or fall and stuff like that. But a one semester delay is no problem at all. Danny, you want to add anything to that?
No, it's not a problem. There's a lot of students who will come into the university who are entered not into HAJUM as pre-majors, but arts and sciences as pre-majors, and discover comp sci that way. They don't come in with the interest, and they'll start in their spring first year. We also do have a decent amount of students who will enter into computer science in their first semester of their sophomore year. So it really just depends on what your individual trajectory is on your academic journey, really. So I always tell people with U of R students, where there's a will, there's a way. Luckily, you've got the flexible cluster system, ways to overlap courses between majors and minors, between even majors and clusters. So if there's something that you want to get done, usually there's a way to get it done at U of R. So a delayed start in a major is by no means a hurdle to graduating on time. So next question, does it make sense to double major in comp sci and brain and cognitive sciences? I will at least answer, we do tend to graduate at least one double major in BCS and comp sci a year. I think we might have had one or two actually in the class of 2020. So it's not a common double major, but people do accomplish it.
Yeah, I would say it's a challenging double major. If that's what you're interested in, though, and you can do the work, and and it's gonna be a grind, it can be really great. My research career was spent at the intersection of computer science and cognition and language. So really in the core of cognitive science. And so I personally think that is a really interesting combination to do. But it's not that easy, and you'd want to talk to advisors in both disciplines and make sure, you kind of know what you're signing up for. Another possibility, though, is to focus, let's say, on BCS and add the computer science courses that are going to give you the tools that you want. And if that doesn't take you all the way to a major, whatever. You're still going to have the tools that you want and need, and you're still going to be able, when you go to the next stage in your career and you go to talk to employers or talk to graduate schools, you'll be able to, you'll know what you're talking about in both disciplines. So, but yeah, so it's possible. It's not easy. Like Danny says, we do usually have a couple double BCS majors. They're often in my AI class. So yeah, it's possible. There's lots of interesting people. Professor Jacobs, who's from the BCS department, is also a computer science faculty member also. So he's a great person to talk to about that, just for a perspective.
And I will also add too, if you are in BCS or in comp sci and you're interested in one or the other, and this goes for really any double major opportunity, this is also a good way to talk to your UG coordinators, because we can connect you with the students in the department who are doing the same things. You know, so if you're a first year or a sophomore and you're saying, hey, I really want to do a double major in comp sci and BCS, you know, the UG coordinators are the ones who know what all of the students in the department are doing. So we can look up the other students who are doing that double major and say, well, this person is doing that. I can connect you to, if you want to chat and see, you know, what worked for that person, what courses they took. So that's a good way to connect with your peers as well, is through double majoring and asking your fellow students, what did you take? What was that course like? And really use that peer mentoring connections that you can get through the department. CSUG is a great way to do that, and so is Women in Computing and Minorities in Computing as well. Okay, so next question. If we have never touched anything computer science related before, what class should we start with?
So I think it depends, you know, on your background and your experience and what interests you besides just the computing. So, you know, if you're interested in science, but you haven't done programming or computing before, that's one thing. And there you might think about taking Intro to CS, CSE 171, and discrete math. If you're interested in computing but haven't done it, don't really think of yourself as a science person, maybe didn't do a lot of STEM courses in high school, or they didn't, you know, they weren't your thing, then I would strongly suggest that you start with Computer Science 161, Intro to Programming. It'll get your feet wet with actually tools that you can use for the rest of your career. You could not do any more computer science after that, and you would have some tools that you could use for whatever you ended up doing afterwards. So Computer Science 161, and then we could talk about, you know, which math course to take, whether it's Foundations of Calculus or Discrete Math, or maybe you don't do a math course in your first semester because you're not really thinking about a computer science major. You just want to see what computing is like. You take Computer Science 161, and if it works out for you and you're interested in it, then you can build a whole computer science major after that. So I think that's where I would sit. I would ask you, you know, if we were sitting together, I would look in your eyes and I would try to figure out, you know, how do you feel about that stuff? And so you can ask yourself, and you can't go wrong really with one or the other. So, but 161 is designed for people with no experience, teaches them programming. Computer Science 171 is for people with no experience of programming, but it's going to push them towards the science of computer science by the end of the course.
Next question, can you take some of these 6 courses, and I assume they mean the 6 core courses, at the same time?
Yeah, you're going to find that, so what you're going to do is you're going to get out a piece of paper and you're going to divide it into 8 sections, and you're going to put courses in each of those as you try to figure out, how am I going to get from here to there? And we don't usually spend a lot of time talking about all the subsequent terms and years of your college career, because honestly, the important thing is to get a good start. And so we focus on that first semester and maybe the first year. But yeah, you definitely can take them. There are some prereqs. There's a couple of prereqs between them. But yeah, you will in fact have to almost certainly take at least one and probably 2 semesters where you take 2 core courses at the same time. And I'll just say it right now, those will be the hardest course semesters of your college career. But you'll be ready for it because you will have taken the stuff that leads up to that. You'll know how things work. You'll know how to work effectively yourself, study group, or whatever it is. And so you'll be able to go in there. But yeah, it'll be challenging. But yes, you certainly can. There are a couple of prereqs.
And another question, can you take both Math 150 and Math 171 in the fall?
So Math 171, for those who don't know, that's honors calculus. That's only allowed, the math department has to let you into it. So they have to say you're okay with that. And if you have a solid math background, they'll let you into that. I'll say two things. Number one is there's a way, if you are in Math 171, Honors Calculus 1, or whatever they call it, you can take Math 150 kind of as an add-on to that. It's called 150A, and it's only available to students who are registered in Math 171. And it basically, if you're good enough to do Math 171, you probably know everything that's in the discrete math course, but we'll double check that by having you do that as an add-on. But you'll be focused on Math 171. So that's the one thing to say. So the answer is yes, you can, but you don't do it by taking both courses, Math 150 and Math 171. The other thing to say is if you have the option to take Math 171, if the math department says you're okay, or you convince them, and you're interested in math, I strongly recommend that you do it. It's a wonderful sequence of courses, and most calculus courses are for people like me who need to understand how to use calculus for some problem, okay? So, or a physicist who needs to use calculus for some problem. The honors sequence in math allows you to understand why calculus works and what are the principles of calculus. So I don't know that I could pass the course, but I've heard from my students and colleagues, that it's a really terrific course. But you do have to talk to the math department about that.
And another question just came in. What are study groups like?
Yeah, so study groups. So that's a great question, and what you find, I think, maybe in general as you get older, is that it's, some people can learn everything on their own, okay? But it's generally speaking, it's helpful to have other people throwing ideas around. And so in our first two courses, 171 and 172, also 161, computer science, we have something called workshops. And you have to sign up for a workshop when you sign up for the course. And those are groups of about 10 to 12 students. They meet once a week, and they're led by a student. So a student who maybe took the course a year ago, sometimes even last term, or maybe they're seniors and they took it in their first year, whatever. They're students, and they lead a sort of group problem solving session, okay? And so you work on problems and you work on them together. And so usually what you get from that experience is you sort of appreciate that, hey, I thought I understood that, but then, this other person suggested another way of doing it, and now I kind of understand it much better. Or I had no idea how to get started on that problem, but then through the discussion, and now I understand how to do it, and I could actually solve it myself now. So the workshops we force you to take in the first two courses to get used to the idea of having a small group of students, no professor, no expert, okay? The student who's leading it, believe me, not an expert. But they know how to lead a group of students. Okay, and so when you move on to the more advanced courses, we don't have official workshops like that anymore. We have workshops led by TAs and things like that. But what you'll find is that you'll want to put together a group of students, like maybe it's for a course, maybe it's for all your courses, it doesn't matter. But a group of, they can be friends, but you don't have to be close friends. You can just be people who are working together. And it's a great way to study and work on things together. And really, to me, I tell students that I wouldn't have passed Calculus 3 if it wasn't for my study group. And I further tell them that no one in the study group actually understood what was going on and knew whether the answer was right. But we did problems from the book, and we could convince, each other that we had gotten the right answer if we ever got there. Okay, and so I mentioned the Computer Science Undergraduate Council and the Women in Computing, Minorities in Computing group, because they can facilitate the creation of study groups, and they can connect you to peer advisors and tutors and things like that that can help you get started. But I think you'll find before you finish your college career that you end up making yourself at least one study group, if not one for every course or for every subject.
Yeah, and I will also just add on, CSUG and WCMIC are also really great because they'll host sort of study sessions around midterms and finals time. So they'll probably host it. I think they host it in the dorms from time to time as well in different places on campus. So they'll have little study sessions. and WCMIC especially, so that's Women in Minorities Computing, they host a lot of like de-stress events as well around that time. So, you know, you have your study group sessions, but there's also a lot of opportunities to sort of relax and chill out and do something fun with your peers through those groups as well. Okay, so that was all the questions in the Q&A stream. I don't know if anybody else has anything else. Any other questions that they want to submit?
Any other questions? And for anyone who's watching this recording, I'll just say that please contact Sarah or myself. Our emails are on these slides and we're easy to find at the Computer Science Department website. Please contact Sarah or me with your questions. We're happy to help you. If you're going to be, go ahead.
Oh, no, one more question came
Sure.
in. I don't really know if we can answer this specifically, but possible career path with Comp Sci and BCS.
The sky's the limit. You know, both of those programs, you know, are research focused. So I would say that you're looking at a research career if you're interested in those two disciplines together. But these days there are companies working on neural interfaces. There are companies working on many aspects of cognitive systems, you know, computer systems that have some degree of cognitive ability. We can talk to computers now, which used to be hard, except for they're still really stupid. So yeah, so there's going to be a lot of possibilities for both commercial careers and research careers. My gut feeling would be that if you're interested in that at an undergraduate level, that, you know, you're probably aiming towards a research career, but it might be a really interesting corporate research lab or project or something, you know. Yeah, there's a lot of options.
Okay. And like I said, that's also the type of thing, if you're interested in both, talk to BCS as well. Talk to that department. Make sure you're getting as many opinions as you can. Talk to the students in those departments. Talk to the faculty in those departments and just see what your options are and see what clicks. Another question, how many comp sci majors are there every year? So I can answer that. So class of 2020, we graduated 119, I believe, 119 students in the class of 2020 for May. Some students will take some extra time and they'll graduate December of 2020. So the total number for the entire class of 2020 will end up probably being about 122 students. Currently, the class of 2021 is at 143 computer science majors. So it fluctuates a little bit every year. I mean, the computer science department, George, you can attest to this, used to be quite small. And I think between the years of 2015 and 2017, the department kind of just boomed. So now we tend to see graduating classes of about 115 to about 130, give or take, you know, 10 here or there.
Sorry.
No, go ahead.
I was just going to say, so, I mean, there's no question there's a lot of computer science majors. That's true everywhere in the world right now. So if you want to really, you know, major that there's only 2 or 3 of you who know what you're talking about, this is not the degree for you. But, you know, there are all sorts of applications, like I said at the beginning, right? Computing is in everything these days. So it's not just the computer science majors. We offer almost 3 times as many seats in the intro courses as we have majors. So the majority of students who are taking intro CS classes are not even ending up as CS majors. They're doing other things and bringing computation to bear on the problems in some other discipline. Okay, whatever it is. So, so that's the deal. There are running around 150 majors. The last year was a little bit more than that. This year was a little bit less, and we're sort of in the middle for next year. You know, I mean, that's just the reality that we live in. I think you'll find at U of R that you can find professors and talk to them. The first classes are big, but the classes get smaller as you work your way up, and eventually you could be involved with a professor's research group. We had several students, I knew them from their first year, that graduated this year, who did real awesome research, presented papers, with the graduate students and the faculty that were doing the research. So lots of opportunities for that, even with a lot of majors.
Okay, another question came in. What kind of support does the department have for people looking into internships, not freshman year, summer, or during the school year? So I would say most of our students do end up on an internship at some point during their undergraduate career. A lot of times I've seen students who kind of will pass on internships to their friends. They'll say, hey, I worked for this company last summer. It was a really great internship opportunity. They want someone else, go apply. So there's a lot of, kind of verbal handoff between students, a lot of connecting among your peers. We also have a really good relationship with the Career Center on campus. A lot of our students will work with counselors in the Career Center to look for internships, apply for internships, work on their CVs and resumes. So those are really great resources. Every year we take students as well to the Grace Hopper celebration, which, if you don't know what that is, it is the largest conference in the world for women in tech across all various industries of tech. A lot of our students will get internships out of that opportunity, whether that's through attending the conference itself or participating in, they have a very large resume database that you can submit resumes to and try to connect with and interview with companies through that. But I will say a lot of internship hunting is on the students. It's not like, schools like RIT have required co-ops that students have to take during the summers. That's not a part of the curriculum here. So a lot of it is your job to find an internship if you want one, but that's not to say we won't help you. Of course, we'll help you in any way that we can. But most of it is coming from the students. And then the Career Center as well is your biggest asset in that.
Yeah, and I'll just add that if you go looking for an internship, and you're quite likely to run into someone from the University of Rochester, and that's always helpful. But the Career Center would be the #1 starting place for internships and things like that.
Okay, so that's answered. So nothing else in the queue. Anybody else have any other questions?
It's been about an hour anyway, so we got to wrap it up soon anyway, but if you got any questions, fire them in there. Otherwise, feel free to contact Sarah or myself. You can find lots more information at our website, lots of information about the degree programs and stuff, but the important thing is to not worry too much about it. We'll get you off to a good start over the summer and get ready to start courses in the fall.
Yeah, so if there are no other questions, like George said, email Sarah with any questions. She's fantastic. She's always happy to answer questions and connect you with resources on campus. And you'll be hearing a lot more from her anyways as the summer progresses.
Okay. Thank you all who are here in person, and thank you who are watching recorded.